Hello, today I will be taking you through my analysis of the South African Police Service tweets using topic modeling techniques. I'll start by providing you with a project background, a description of the dataset, a high-level description of the approach that I followed, a few interesting insights that I gained from the analysis, and lastly, my conclusion, limitations, and recommendations for the study. As we all know, the crime rate in South Africa is high, with the country ranked third in the world in terms of the crime rating index. Furthermore, public trust in the South African police services was at an all-time low of 27% as recently as 2021. While crime remains a complex challenge with many socioeconomic contributors, could an analysis of the social media discourse help us identify potential focus areas for the South African police services in order for them to rebuild this public trust? The aims of the project to basically identify a suitable topic modeling technique that can be used to analyze data related to South African police services and identify common topics that are related to the South African police services that may serve as early warning signals or help the South African police services to improve their service to the public and rebuild that public trust. The dataset consisted of 1.6 million tweets for the period of 2021 to 2023. 90% of these tweets were English, and they were used for the analysis. The average tweet consisted of around 200 characters. The approach itself was informed by a literature review, and it starts off with the model selection. The model selected for this particular analysis was that of LDA and a BERTopic model. In terms of data pre-processing, the data pre-processed here fed both the LDA implementation as well as the BERTopic implementation, and it involved converting the text to a lowercase, removing URLs, mentions, hashtags, digits, and emojis that wouldn't necessarily contribute to the identification of topics. In terms of the LDA implementation, two models were implemented. The first with a bag of words corpus and the second with the TF-IDF corpus. Further processing, pre-processing or further processing rather was required on the data from step 2, and this included tokenization, stopword removal, and lemmatization. Findings were visualized, and for each model, topic coherence was computed. With regards to BERTopic, no further pre-processing or processing of the data was required before use in the model. The first step was to basically create the corpus embeddings using the sentence transformer. I then initialized the count vectorizer to remove stopwords. I could fine-tune the UMAP, HDB scan, and the representation model, which basically serve as inputs into the BERT model. And then lastly, visualize the findings using BERT's pre-built visualization and compute topic coherence for the BERTopic model. All three models were evaluated in terms of topic coherence on varying sample size of tweets. Some of the results that I found, I think if we consider the word clouds for topic 6 of each model, you'll see that the keywords identified in each topic are vastly different. I think what's interesting is that with BERTopic, we can potentially add a topic name to the topic. We could call it drugs or substance abuse, something along the lines of that. I think it's less easier with the LDA TF-ID corpus, and I think the least easiest with the LDA bag of words corpus. In terms of topic coherence, BERTopic did perform better than both the LDA implementations on all experiments run. And then just in terms of conclusions, again, I would recommend BERT for future work on this particular data set. I think what it does well is it creates topics with more semantically similar words as opposed to the LDA implementation. I think a key issue with BERT is that it is computationally expensive and it does take much longer to run as opposed to LDA. So if you want like a quick quick analysis of a corpus, maybe LDA is the way to go. Again, I think this is a limitation of the study. I was unable to run, the full complement of tweets using BERTopic. It kept crashing. And similarly, topic coherence was difficult to calculate the moment I went beyond 120,000 tweets. So I'd like to run these I'd like to run this model through a GPU or CUDA configured machine. And then lastly, my recommendations for future work would be to add a sentiment analysis on the tweets and subsequently, the topics identified for each tweet to enhance the understanding of the public context about certain events. Thank you.